Okay, students, next topic. Okay, students, next topic. Angle of repose and angle of friction. We can prove both are equal to each other. See that part I am discussing now. Already in this friction we discussed mu s is equal to tan phi. Coefficient of static friction mu s is equal to tan phi. Here phi is the angle of friction, mu s is the coefficient of static friction. So I am taking this is equation 1. And next from this diagram, from rough inclined surface, here theta is angle of inclination. Same this diagram we discussed in before topic. So this is weight mg. If it makes an angle theta, this is a horizontal component which is mg cos theta, and this is normal force n, and along this direction mg sin theta acting. This is mg sin theta. But the motion of block which is opposing by frictional force F. Opposing by frictional force F. Next, so here three cases we can discuss. First case, if theta is equal to alpha. So what is alpha? Angle of repose. Angle of repose. So already we discussed the statement of angle of repose. So it is at particular angle of inclination, the body just ready to slide down the inclined surface. It means when theta is equal to alpha, the block which is placed on the inclined surface just ready to slide down. And if theta less than alpha, the block still rests on the inclined surface. If theta greater than alpha, the block in motion on the rough inclined surface. You know, block in motion means static frictional force converting into kinetic frictional force. Now, first case, I am discussing now that theta is equal to alpha. Angle of inclination is equal to angle of repose. So it means this frictional force F is equal to mg sin alpha, then only block just ready to slide on the inclined surface. So just I am substituting in these equations, theta is equal to alpha. From diagram, normal force acting on a block n is equal to, which is mg cos alpha, and frictional force F is equal to, so this is mg sin alpha. But F is equal to mu into n, but it is just ready to slide on the inclined surface, means static frictional force only. Then F is equal to, we know mu s into n is equal to, so mg sin alpha. Then mu s is equal to, but we know n value from diagram. What is that n value? Mg cos alpha. So if substituting n value, mg cos alpha, which is equal to mg sin alpha. So from diagram, mg and mg cancel. Therefore, mu s is equal to sin alpha by cos alpha, which is equal to tan alpha. This is equation 2. Already from equation 1, we know coefficient of static friction mu s is equal to tan phi, and from second equation mu s is equal to tan alpha. So from equation 1 and 2, we can equate these two. Therefore, from equation 1 and equation 2, tan alpha is equal to tan phi. So both sides tan cancel, then alpha is equal to phi. So angle of repose is equal to angle of friction, both are equal. So this is one topic here. And the next one, suppose if the same block is moving downward direction, we know acceleration, velocity, and time taken. At the same time, if the block projecting from bottom to top level, so then how much force required for the block to moving upward direction? So for this one, for the block moving upward direction, the required force F is equal to, we know mass into acceleration, then force F is equal to m into acceleration A value. We know when block moving downward direction, that acceleration A is equal to g into sine theta minus mu k cos theta. But here block moving upward direction, just to change sign here. Then in place of A, I am substituting m into g. It is a sine theta plus mu k cos theta. This is the force required for the block moving upward direction. Next, one more topic I'm continuing here. Friction on the vertical surfaces. Friction on vertical surfaces. So here three cases we have. First case I'm discussing here. So this is vertical surface, and one block is compressed towards the vertical surface with a force F. This is the compressional force by the block towards the vertical surface with a force F. This force N exactly balancing the normal reaction which is acting on the body, and weight of block mg acting downward direction. And for equilibrium position, the downward force, which is weight of the block, should be balancing by frictional force, which is acting upward direction. So at equilibrium position, frictional force F is equal to mg, but frictional force F is equal to mu s into n, because block is at rest. Then static frictional force acting is equal to mg, then static frictional force mu s into, but from diagram clearly this normal force n is equal to that for normal reaction n is equal to compressional force against the wall. Then in place of n we can substitute here F is equal to weight m into g. So therefore, coefficient of static frictional force mu s is equal to mg divided by force F. This is first case. We calculated here the frictional force between coefficient of static frictional force between block and vertical surface. Second case B. So some amount of minimum force required in the same example, minimum force required for the block moving upward direction. So from diagram clearly, this is a compressional force against the vertical surface on the block. This is normal reaction which is acting on the block, but weight always acting downward direction. This is weight mg. So for the horizontally, the block is pushing upward direction. Then this minimum force required, F minimum. So, but if the block tries to moving upward direction, the frictional force which is acting downward direction, because frictional force always opposing the motion of the block. Therefore, total here, frictional force F acting downward direction, weight of the block mg also acting downward direction. Therefore, from diagram clearly, we can write that minimum force acting on the block is equal to, so mg plus frictional force. Therefore, F minimum is equal to mg, but frictional force F is equal to mu s into n. But we know n is equal to compressional force which is acting on the block. Then this final equation F minimum is equal to mg plus mu s into n is F. This is the minimum force required. And one more case in this one. So if the block or book something which is compressing by using the two hands or two forces at equilibrium position, we have to find here frictional force or coefficient of static friction. See, like this. This is imagine one hand and this is another hand. Between two hands, if a person compressing the book, so here frictional force acting upward direction, and here also frictional force acting upward direction, and weight of the book acting mg downward direction. So at equilibrium position, so the frictional force which is acting upward direction F plus F is equal to downward force mg, F plus F 2F is equal to mg, then 2 into frictional force F is equal to mu s into n, which is equal to mg, then coefficient of static friction mu s is equal to mg divided by 2 into n, but we know n is equal to that compressional force F, then which is equal to mg by 2 into F. This is the coefficient of static friction between, so those two hands and the book.